Military specification designs within Navy yards encompass a wide range of projects and require a deep understanding of naval engineering principles and military standards. Expertise in this area involves working on diverse projects such as the design of new ships, the renovation of existing vessels, and the development of cutting-edge technologies specifically tailored for naval applications. When designing new ships, naval engineers must consider numerous factors including hull design, propulsion systems, weapons systems, and communication systems. The design process typically involves extensive computer modeling and simulation to optimize performance and ensure structural integrity. Naval architects and marine engineers collaborate to create vessels that meet stringent military requirements for speed, maneuverability, and survivability. The design of a new class of guided missile destroyers, for instance, demands meticulous attention to detail to integrate advanced radar, missile defense systems, and anti-submarine warfare capabilities. These ships are designed to operate in high-threat environments and must be capable of effectively engaging a variety of targets. The renovation of existing ships is another critical aspect of military specification designs. This work often involves upgrading outdated systems, repairing structural damage, and extending the service life of vessels. Renovation projects can be complex and challenging, requiring careful planning and coordination to minimize downtime and ensure that the ships are returned to service as quickly as possible. For example, the renovation of a fleet of aircraft carriers involves modernizing flight deck equipment, upgrading aircraft launch and recovery systems, and improving the ship's defensive capabilities. These upgrades are essential to maintain the operational readiness of the carrier fleet and ensure that the ships can continue to support naval aviation operations for years to come. The development of new technologies for naval applications is also a key area of focus in military specification designs. This work involves researching and developing innovative solutions to address emerging threats and improve the performance of naval systems. New technologies may include advanced sensors, unmanned vehicles, and new types of weapons. For instance, the development of a new system for launching and recovering aircraft from ships requires expertise in aerodynamics, control systems, and materials science. These systems are designed to improve the efficiency and safety of flight operations, allowing aircraft to be launched and recovered in a wider range of sea conditions. In addition to ship design, renovation, and technology development, military specification designs also include the design of naval bases. These bases provide essential support for naval operations, including berthing facilities, maintenance facilities, and training facilities. The design of a new type of naval base must consider factors such as security, environmental impact, and community relations. Naval bases are designed to be self-sufficient and resilient, capable of supporting naval operations even in the event of natural disasters or other emergencies. A thorough understanding of military specifications is essential for anyone working in military specification designs. These specifications provide detailed requirements for the design, construction, and testing of naval systems and equipment. Military specifications cover a wide range of topics including materials, welding, electrical systems, and safety. Compliance with these specifications is critical to ensure that naval systems are reliable, durable, and safe. Military specifications are constantly evolving to reflect advances in technology and changes in military requirements. Staying up to date on the latest specifications is essential for naval engineers and designers. The unique challenges and requirements of naval design demand a high level of expertise and attention to detail. Naval engineers must be able to work effectively in a team environment and communicate complex technical information clearly and concisely. They must also be able to solve problems creatively and adapt to changing circumstances. Naval design is a demanding but rewarding field that offers the opportunity to make a significant contribution to national security. Being a member of professional organizations such as the American Society of Naval Engineers, or ASNE, is a valuable way to stay connected with the naval engineering community and learn about the latest developments in the field. ASNE provides a forum for naval engineers to share knowledge, network with colleagues, and advance their careers. The The Society also plays an active role in the development of new standards and specifications for naval design. Military specifications often dictate the materials used in construction. For example, specific grades of steel are required for hull plating to withstand the stresses of sea conditions and potential combat damage. Aluminum alloys are used in superstructure components to reduce weight and improve stability. Composites are increasingly being used for non-structural components due to their lightweight and corrosion resistance. Electrical systems on naval vessels must meet stringent requirements for reliability and safety. Wiring must be properly insulated and shielded to prevent electromagnetic interference. Backup power systems are essential to ensure that critical systems remain operational in the event of a power outage. Electrical components must be designed to withstand shock and vibration. Welding is a critical process in shipbuilding, and military specifications require that all welding be performed by certified welders using approved procedures. Welding procedures must be carefully controlled to ensure that welds are strong and free of defects. Non-destructive testing methods, such as radiography and ultrasonic testing, are used to verify the integrity of welds. Safety is a paramount concern in naval design, and military specifications include detailed requirements for fire protection, damage control, and personnel safety. Fire suppression systems must be designed to quickly extinguish fires and prevent them from spreading. Damage control systems must be capable of containing flooding and repairing structural damage. Personnel safety equipment, such as life rafts and survival suits, must be readily available. The design of naval systems must also consider human factors. The layout of workstations and control panels must be designed to minimize operator fatigue and errors. Ergonomic principles are used to ensure that equipment is comfortable and easy to use. Training programs are essential to ensure that personnel are properly trained to operate and maintain naval systems. When working with electrical systems, there are key things to consider. Firstly, voltage drop is a significant concern in naval electrical systems, especially over long cable runs. Military specifications often impose stricter voltage drop limits than commercial standards to ensure that equipment receives adequate power. Secondly, grounding and bonding are critical for safety and to prevent electromagnetic interference. Military specifications require that all equipment be properly grounded and bonded to a common ground plane. Thirdly, electromagnetic compatibility, or IMC, is a major consideration in the design of naval electrical systems. Military specifications require that equipment be designed to minimize electromagnetic emissions and to be immune to electromagnetic interference from other sources. Shielding, filtering, and grounding techniques are used to achieve EMC. Fourthly, power quality is essential for the reliable operation of sensitive electronic equipment. Military specifications may require the use of power conditioners and uninterruptible power supplies, or UPS, to ensure that power is clean and stable. Fifthly, cable management is important to prevent damage to cables and to facilitate maintenance. Military specifications may require the use of cable trays, conduits, and other cable management systems. Sixthly, connector selection is critical for ensuring reliable connections in harsh environments. Military specifications often require the use of ruggedized connectors that are resistant to vibration, shock, and corrosion. Seventhly, testing and certification are essential to ensure that electrical systems meet military specifications. Equipment must be tested to demonstrate that it complies with all applicable requirements. Certification may be required by a third-party testing laboratory. Eighthly, documentation is important for maintaining a record of the design, installation, and testing of electrical systems. Military specifications may require the preparation of detailed drawings, specifications, and test reports. Ninthly, safety is paramount when working with electrical systems. Personnel must be properly trained and equipped to work safely with electricity. Lockout-tagout procedures must be followed to prevent accidental energization of equipment. Tenthly, maintenance is essential to ensure that electrical systems continue to operate reliably over time. Regular inspections, testing, and maintenance are required to identify and correct potential problems. The design of a new type of naval base involves unique considerations related to electrical infrastructure. Firstly, redundancy is a key design consideration. Naval bases often have multiple substations and distribution feeders to ensure that power is available even if one source is lost. Secondly, security is a major concern. Electrical systems must be protected from sabotage and unauthorized access. Fencing, lighting, and surveillance systems are used to deter intruders. Thirdly, power quality is essential for supporting sensitive electronic equipment. Naval bases often have power conditioners and uninterruptible power supplies, or UPS, to ensure that power is clean and stable. Fourthly, energy efficiency is increasingly important. Naval bases are implementing energy conservation measures to reduce their energy consumption and costs. Fifthly, renewable energy sources, such as solar and wind power, are being integrated into naval base electrical systems to reduce reliance on fossil fuels. Sixthly, microgrids are being used to improve the resilience and reliability of naval base electrical systems. Microgrids can operate independently of the main grid in the event of a power outage. Seventhly, smart grid technologies are being used to optimize the operation of naval base electrical systems. Smart grids can monitor and control power flow, detect and isolate faults, and improve energy efficiency. Eighthly, cybersecurity is a major concern. Naval base electrical systems must be protected from cyber attacks that could disrupt operations. Ninthly, surge protection is essential to protect sensitive electronic equipment from damage caused by lightning strikes or other surges. Tenthly, grounding and bonding are critical for safety and to prevent electromagnetic interference. The design of electrical systems for naval vessels and shore facilities must comply with the National Electrical Code, or NEC, as well as military specifications. The NEC provides minimum safety standards for electrical installations. Military specifications often impose stricter requirements than the NEC in certain areas, such as voltage drop, grounding, and electromagnetic compatibility. Section 310.15 of the NEC covers ampacity of conductors. This section provides tables that list the allowable ampacities of different types of conductors based on their size, installation type, and installation conditions. When selecting conductors for naval applications, it is important to consider the ambient temperature, the number of conductors in a raceway, and the presence of other heat sources. Section 250 of the NEC covers grounding and bonding. This section provides requirements for grounding electrical systems and equipment to protect personnel from electric shock and to prevent equipment damage. Grounding is particularly important in naval applications due to the presence of salt water, which is a good conductor of electricity. Section 400 of the NEC covers flexible cords and cables. Flexible cords and cables are often used in naval applications for connecting portable equipment and for temporary wiring. These cords and cables must be properly sized and insulated to prevent overheating and electric shock. Section 430 of the NEC covers motors, motor circuits, and controllers. Motors are used extensively on naval vessels for driving pumps, fans, and other equipment. This section provides requirements for motor protection, motor control, and motor wiring. Section 440 of the NEC covers air conditioning and refrigeration equipment. Air conditioning and refrigeration systems are essential for maintaining comfortable temperatures on naval vessels. This section provides requirements for the installation and wiring of air conditioning and refrigeration equipment. Section 445 of the NEC covers generators. Generators are used on naval vessels to provide backup power in the event of a power outage. This section provides requirements for the installation and wiring of generators. Section 450 of the NEC covers transformers. Transformers are used on naval vessels to step up or step down voltage. This section provides requirements for the installation and wiring of transformers. Section 455 of the NEC covers phase converters. Phase converters are used on naval vessels to convert single-phase power to three-phase power. This section provides requirements for the installation and wiring of phase converters. Section 480 of the NEC covers storage batteries. Storage batteries are used on naval vessels to provide backup power for critical equipment. This section provides requirements for the installation and wiring of storage batteries.